Right, so in this question we can see that ABCD is a square, so that means that the side lengths are equal. We can also see in our diagram two triangles that look kind of similar because they have a right angle. So perhaps there's something there. If we take these two triangles here, perhaps we can find a relationship between them. Well, we've looked at the information for the sides. What about for the angles? Now, if this is alpha, then we know that because in triangle ABE, these two angles have to be complementary. But also, because it's a square, we know that this angle here is a right angle because, as we know, it's a square. That means that this angle here is also 90 minus alpha, and we can continue this logic across into triangle AFD to say that this angle is alpha. So with all that information, what type of triangles do we have now? Well, we can see that we have a matching angle here and here. We have the side length here, and so if we had either the other side or the other angle, well, here we're not sure what this is, but we do know here this angle alpha is matching with this, is equal to this one here. So we can say for sure that the triangles here are congruent. So which triangles? Well, they're triangle ADF, remembering the notation here for congruency and for triangle. Now A is 90 minus alpha, that matches with B in the other triangle. D, alpha, will match with A. And the last vertex there is at E. And so the reason that they are similar, normally we'd write this on the right, but I've run out of room there. Well, sorry, there's the side in the middle and the angles adjacent to those also equal. So, this helps us because we're looking for BE plus FD. So let's call that something on the diagram, maybe X and Y. So BE here, X, FD, Y. And so we need to match up some corresponding sides in here. So BE, B and E matches with AF. So we know the length of AF actually. AF here is equal to 8. And maybe I can just write that here using the correct notation there. And so if we call BE X, we can see that AF on the diagram is 8. Now what about for DF? Well, DF, if we see here, D and F would match with the side AE. It'd be equal because the triangles are congruent, AE. So AE there is 6. So if DF is Y, we can see that Y would be 6. And the question's asking, what's the value of X plus Y? Add these two together. I think we'll agree the answer is 14. So the important part of this question was using congruent triangles to find the matching or corresponding lengths.